Hi everyone, I am Deep Mode. Today I will talk about how software defined networks or SDN is changing the future of network. In simple words, we will see how networking is shifting from old hardware based systems to smarter, software controlled ones that are faster, flexible, and much easier to manage. Let's start with the reason behind SDN's evolution. Today, computer networks are everywhere, powering cloud computing, online banking, 5G, and billions of IoT devices. But traditional networks were built for simpler times. They depend on hardware based systems where router and switches are configured manually one by one. This process is slowly an error and doesn't scale well when network grows or when traffic pattern changes. In other words, the traditional approach like flexibility and business need networks that can adapt instantly. That why the idea of software defined networks came into existence to make networks smarter, faster and programmable. So what is SDN? In simple words, SDN is a way of designing managing network through software instead of relying on hardware. It separates the two key part of networks, the control panel and the data panel. The control panel which decides how data should flow and the data panel which is responsible for actually moving the data. By moving control logic to a software-based controller, the network administrator can manage the entire infrastructure from one central dashboard. No need to log into every device separately. This makes network management faster, more efficient, and way more flexible. In traditional network, every device, like a router or switch, has its own brains. Each make independent decision about where to send the traffic. This means if you have 100 devices, you need to configure each manually using command line tool which can take hours or even days. With SDN, all the control is moved to a central controller. This controller communicates with all devices using software APIs. The result, you can delay policy, manage routing, and adjust bandwidth across the entire network in seconds. It is like upgrading from typewriter to fully automated computer system, faster, smarter, and easier to. SDN has three main layers and each plays an important role. First, the application layer. This is where the software tools and business application operates. Things like firewall, load balancer, and monitoring tool sit here. Second, the control layer. This is the brain called SDN controller. It takes requirement from application and decides how the network should behave. Finally, the infrastructure layer. This is the physical or virtual hardware like a router, switches, and access point that actually forwards the packet based on instructions from the controller. These three layers work together through standardized infrastructure, making the whole system dynamic and centralized. To understand SDN better, think of it like traffic light in a big city. In traditional system, each traffic light operates independently. It doesn't know what's happening at the next intersection. This often causes congestion. Now imagine a central command center controlling all the traffic lights. In real time, it can see the whole city, adjust traffic signal dynamically, and reroute traffic if any accident happens. That's exactly what SDN does for the data flow. The SDN controller monitors the entire network and optimizes the flow of information based on demand, reducing delay and preventing bottlenecks. Now let's talk about main advantages. First, centralized management. Network admins get a single unified view of the entire network, making configuration simple and consistent. Second, automation. Repetitive tasks like VLAN setup or access control can be handled automatically by script. Third, cost efficient. SDN use regular hardware, so organizations don't need expensive brand specific devices. Fourth, flexibility. It is much easier to roll out new services or adjust network behavior instantly. And lastly, improved security. Because policy are controlled centrally, they can be updated and enforced across all devices in the second, which reduces vulnerability. SDN isn't just theory, it is already being used. Cloud companies like Google, Amazon, and Microsoft use it to manage global data centers. Telecom operate use SDN for 5G network slicing. Even universities and large offices use it as access control and automation. And it is great for IoT when millions of devices need smooth and secure connection. Of course, there are some challenges. Shifting traditional to SDN network isn't easy. It needs planning. Engineer must also learn programming and automation skills like using Python and APIs. And since SDN has a central network, if it fails, the network can go down. So backups are very important. Now let's look at future. SDN is often praised with something called Network Function Virtualization (NFV). NFV replaces hardware-based functions like firewall, VPNs, and load balancer with software that runs on general-purpose services. Together, SDN and NFV make networks incredible, dynamic, and scalable. This combination is moving towards self-driving or automation network systems that monitor themselves, predict issues, and fix problems automatically. In coming years, this will redefine how companies build and manage digital infrastructure. To wrap up, SDN represents a major shift in how we think about networking. Thank you all for listening. I hope this gave you a clear idea how SDN is challenging the network world and why is it existing technology to learn about.